Good morning students, welcome to the session on operating system. In our previous lecture we have started the concepts of your CPU scheduling. In that we have seen what is program, what is process, what is job, and what is job scheduling, and long term scheduler, and a short term scheduler, medium term scheduler. These we have seen in our previous lecture. Now today's lecture we are going to see CPU burst and IO burst, as I have discussed in the previous lecture. Okay, now let us try to understand what is the CPU burst and what is IO burst. Okay, process execution, any process execution will contain these two cycles. I can say they are process execution cycle, process burst cycle, or as IO burst cycle. Okay, now generally when we are executing any process will be executed by following these particular cycles. I can say suppose whenever I am trying to execute my process will require what? CPU will be given to your process. Whenever a process is given for CPU, whenever a process or else whenever CPU is assigned for a process, then your process will get executed. When it is executing itself, then it may need some IO devices, or else it may be waiting for some IO event to occur, or else it will be waiting for some other results to occur. But in that time we will be putting that into our waiting queue in order to occur some event, right? Until or unless it will be given with some input output, it will be in a waiting state. Then your CPU, your process will be in CPU burst until or unless it is executing itself. When it is waiting for the input output, then it will become IO burst, which is followed by another. So whenever it is completing its IO request, then it will come to your CPU burst again. It will be taking the processor and it will be executing. And in middle of the execution, again it will be requesting for some IO devices, or as input output devices, I can say, or as some other event to occur. It will be waiting for, and this will be given with some IO, and again it will be taking CPU and it will be executing itself. In middle of the execution, again it will be requesting for IO devices, again it will be taken. Until or unless the process completes its execution, it will be doing the same cycles, I can say, that is CPU and IO burst cycle. First it will be taking the CPU in order to execute, but in middle of the execution it may require some IO, that is input output devices, or as input output results, I can say. Some processes will wait for the results of some other processes, I can say. Okay, some processes will wait for some other processes to complete its execution. The result will be taken as input. Okay, in that particular case, IO burst will be executed. When it is in the execution, then the CPU burst will be taken. The cycle will be moved from one state to other state in order to complete the process execution, I can say. Eventually, the final CPU burst ends with a system request to terminate the execution. Whenever a process is executing, it will be taking the IO, but it won't end with the IO. Why? Because process execution will complete at your CPU only. By the CPU, you should know that the process has been ended, process has been successfully executed. That is the reason we are saying that eventually the final CPU burst ends a system request to terminate the execution. Whichever the process that you are going to execute, it will be end, or else it will be terminated by your CPU, I can say. That is the reason it will be in CPU burst when it is ending. Okay, I hope it is clear. Now let us try to understand what is the CPU burst and IO burst is. Whenever a process is in execution, that will be taken by your CPU. Okay, processor will execute those processes. When CPU burst is when the process is being executed in the CPU. By the processor, your process should execute. Whatever the time that is taking in order to execute, they will fall under CPU burst. CPU burst. That is the reason they have given definition like this one. CPU burst is when the process is being executed in the CPU. Why we are calling that as being executed? Whenever we are executing, we may require number of IO devices, IO input output operations, I can say. For that reason, we will be taking the processor from your process I can say. That is the reason we are saying being executed. Continuously, it won't do the execution. It may wait for the IO. It may wait for the event to occur. Like, right? Whenever we are giving the time for the process in order to execute it by the CPU, that time is called as CPU burst. I hope it is clear. Okay. And the next one that we are having is IO burst. Okay. Then input output burst. Input output burst is when the CPU is waiting for the IO for further execution. Whenever a process is in waiting, whenever a process the processor is waiting for the IO devices to occur, IO event to occur, then that time is called as IO burst. When your process is in execution, the processor has taken your process, when it is executing itself, when it is waiting for the IO to occur, or else whenever it is waiting for the input output devices, whenever it is waiting for some event to occur, then that time is called as IO burst, I can say. These are very mandatory things that you need to know before going for the CPU scheduling. Okay, as I told you people in the earlier session, we will be discussing about the dispatcher in our next lecture. I hope it is clear to you people. I will be when we are executing the processes, Mama, this will be assigned with the processor, I can say. Okay, whenever we are assigned with the processor, we'll be executing some instructions. Let us see that how we will be having the CPU and IO burst cycles. See, this is an example where you can easily understand. See, whenever a process, say suppose process 1 is given to your processor, CPU will be executing. When it is executing, it will fall under what? CPU burst. So it will be loading and storing, and it will be add some, it is acting some, it is executing some instructions, loading and storing, and add and store and read the file. When we are executing this read file, it needs some what? Input. Then it will be given to your IO burst. It will be waiting for the input, right? Then it will be in wait for IO devices. That is what it will fall under IO burst. Again, the process, when it is taken, when it is reading, then store increment. Whatever the data that has been taken, that will be stored into your devices, and indexes will be. Process may be changed, okay? Why? Because when it is in IO, you should attain what? CPU maximum utilization. In order to not have any time wastage, we will be assigning some other process to your CPU, I can say. Then it will be doing this store increment index, right, which is in your CPU bus. Means CPU is executing this. But after this, write to file. When you are writing the file, you need what? IO devices. Then it will be taking this. It will be typing something. It will be giving some data to write on the file, and it will be taken to your IO bus. And then the CPU will get execute the load and store add, which is similar to this one. It will be executing this. And whenever it is needed with the waiting IO, then it will be waiting for the IO burst will come. Like that, we will be executing the same things. That is the reason we are saying CPU and IO burst cycles. Why? Because it will continuous until or unless your processes will get executed. Okay, but why we are doing this? Why the CPU scheduling is very important means, see, whenever a unit processor is there now, we'll be having only one processor, so that we will be executing only one process. But in case of multi-programming process, we try to have the maximum CPU utilization. We will be putting one or the other processes in order to execute. CPU will not say, I will be taking rest, I will be sitting idle. No, it won't say like that. It will be asking for the processes to execute. Okay, I am idle now, I can execute one more process, just assign me. So in that way, you need to execute the process one after the other. So your CPU utilization will be in a maximum extent, I can say, when you are using this. I hope it is clear. We'll see a few more details in our upcoming lecture. Okay, that's it for now. Thank you.